So I think to start with, everybody loves to have the idea of scale, but it's about who we're dealing with and who we're talking to often has a very big bearing in that conversation. So if you're speaking with the maintenance technicians and teams that are actually doing the job, the boots on the ground, their world is really related to their plant. And the context of scale for them is about scaling the assets they are measuring and monitoring within that plant. So I'm trying to define what scale means. But for example, if I'm speaking to a chief operating officer that's responsible for 5 plants or 20 plants, scale to them means actually deploying the same solution across multiple plants and increasing their visibility of the health and performance of those plants.
Welcome to the Trend Detection Podcast, powered by Siemens. And now your host, Niall Sullivan.
Hello, and welcome to the latest episode of the Trend Detection Podcast. I'm really pleased to be joined today by another external guest, an external expert, Nick Leeder, who's actually an advisor and coach to a lot of manufacturing businesses. And we have has a lot of insights to share, and particularly around the topic today that we're talking about, which is all about why predictive maintenance projects don't scale. And anyone who listens to this podcast on a regular basis will know we've covered this at lots of different angles as well. It's always a big challenge. And I think from a customer perspective, it's sort of knowing where to start, when's the right time to scale, what they need to think about, and all those things we're going to talk about today. But I guess before we dive into the topic, I'll just hand over to you, Nick, just to sort of introduce yourself and we'll go into it. So over to you.
Brilliant. Well, look, thank you for the opportunity today to speak with you around this topic. My background is really 30 odd years, which is really worrying actually when I start looking at the amount of grey hairs on my head. Working in manufacturing businesses exclusively on the transformation of operations in engineering and in manufacturing. And I've done that across the world for big names like SKF and Dyson and Philips, but also for mid-sized businesses as well that are seeking to gain competitive advantage or improve operational efficiency. So I spend my days brilliantly, and I really enjoy it every week, getting out to manufacturing businesses and understanding what they're doing and seeing how all these buzzwords we deal with on a daily basis in the world of digital actually have something meaningful to their organization.
Excellent. And I guess just to, before we go into sort of the, particularly about, the scaling of predictive maintenance projects, but you mentioned some big names there as well, but what are some of sort of the key challenges that they're sort of facing at the moment when you're having these conversations? What are they coming to you for advice about?
So, that's probably the beauty of my job. It is very, very varied. So, ultimately, most people need to get stuff out the door on time, at cost, at quality, and do that safely as well. That last bit often gets missed in that whole conversation. Some of my topics are generally around, businesses sitting back and saying, look, we've got a really aggressive growth plan over the next 2 to 5 years. How do we do that? Do we need to build a new factory? Can we improve performance? How does digital play in that? And digital doesn't have to be clever. I've got a current newsletter series called the Manufacturing Mousetrap. There's over 4,400 patents for mousetraps in the US. If you don't know that, only one works really well. I've seen some crazy ones with guns trying to, a mouse eating the cheese and a gun shooting them. But in reality, it's a finding about how digital gives them simple solutions to their operational problems today. Now, that could be a new ERP or an MRP system. Now, some of my customers have much more broader business challenges, which they help them take them on the next journey. It could be an implementation of a MES system on a production shop floor, or it could be, bringing it back to the context of today's conversation, about how do you stop machines breaking on the shop floor? And that has that downtime and that frustration that appears in the maintenance teams because they can't keep the kit running, to the operations director or the operations manager that's not getting the product out the door when they need to because of lack of availability of equipment. So it could be something about, well, how do you implement a condition-based monitoring or a predictive maintenance solution that helps you get that visibility earlier? So it is, absolutely a broad spectrum of problems that manufacturers face on a daily basis, and sometimes just helping them see the simple things away from all the noise we see in the press and literature on a daily basis of how we can actually get to value quickly.
Exactly. And today we're talking about scale. And I guess to really start that conversation, and we chatted just before, we pressed record a little bit about this, but, in terms of ambition and speaking about predictive maintenance in particular, is there, do you see there's an ambition to sort of scale and make this sort of an enterprise sort of deployment, or is there sort of more reluctance in the market? They're still a bit unsure about the benefits of predictive maintenance, and so want to start a bit smaller. What's your sort of feeling based on your sort of experience?
Look, we all live in the world of budgets for a start. So aspiration and budgets are two different things. So I think to start with, everybody loves to have the idea of scale, but it's about who we're dealing with and who we're talking to often has a very big bearing in that conversation. So if you're speaking with the maintenance technicians and teams that are actually doing the job, the boots on the ground, their world is really related to their plant. And the context of scale for them is about scaling the assets they are measuring and monitoring within that plant. So I'm trying to define what scale means. But for example, if I'm speaking to a chief operating officer that's responsible for 5 plants or 20 plants, scale to them means actually deploying the same solution across multiple plants and increasing their visibility of the health and performance of those plants. So scale to different people means different things. But there are, I guess, a number of really important things that are consistent, irrespective of whether you're talking within your own plant and your facility or within multiple plants and your operations of the company. The first one is it's got to make financial sense. Deploying stuff. I see, I get involved in questions around condition-based monitoring and predictive maintenance quite a lot for companies. And the first tendency is to try and measure everything. And actually starting with, well, look, what assets are actually the most critical assets that when they go down, your line goes down, you can't produce? Or when they go down, it has an impact, but actually it's a very expensive piece of asset or equipment and actually a long lead time item to get a replacement. And you don't want to hold it in stock because that drives your stock levels up and cost and then working capital up. So making sure that there's actually a really clear benefit case of which assets do I really need to measure that make the biggest difference? And then start with saying, well, look, if this goes down, the cost of production, and we all know the business case behind that. But one of the things I spend a lot of time coaching both leaders and people who are trying to get these projects off the ground and to scale is, the mathematics of these things you can demonstrate. I recently read a paper and actually been engaging with the author from Standard & Poor's, S&P, on the financial benefits of predictive maintenance. And it was built on a hypothetical example. And their hypothetical example was 50% of the machines in the factory need monitoring. But then the example was an OEM manufacturer of pumps. Now, I'm going, hold on, what equipment is critical to because typically a lot of predictive maintenance is based on rotating assets and equipment, your compressors, your motors, your gearboxes. You can do oil, temperature, humidity, all these things come together, but really do 50% of your machines need to be measured? The ROI ended up being about 5 microseconds, you turn it on. So let's be honest about it. Let's be real about it and actually bring the real case studies to the discussion. So not a theoretical mathematical case, but you know what? Last week we had compressor number 4 on that line go down and we couldn't produce for, 6 hours. So we lost 6 out of an 8-hour shift because of that. That cost you money. That's real. And the reason why it went down was X, Y, and Z. Now, if we had condition-based monitoring, we would have known about this 2 weeks before. And we could have actually planned an intervention in a planned downtime window or over the weekend that would have avoided that. And you know what? That compressor, that's an example last week. In the last year, we've had 14 of those events on those same bits of equipment. Now, I'm making these numbers off the top of my head. But what you've done is taken an Excel spreadsheet that gives you some very impressive numbers into something that is real, that is pertinent to the people that want to do it. So that ROI becomes really clear, not just in metrics and for the finance guys, but actually examples of where it goes wrong. So that to me would be a great example of getting it over the line. There are a couple of other areas. We also live in the world of legacy equipment. And please don't shoot me here, but a lot of salespeople that go in around predictive maintenance kind of come into this kind of view that you're working on a greenfield site and everything's latest and the most shiniest equipment. You just plug things in and off you go. That isn't the world that most manufacturers live in. And 85%, a study by IDC last year said that 85% of manufacturers find that data silos and integration with legacy equipment are the major barriers to take technologies like predictive maintenance forward. So, understanding that this stuff actually has to be retrofitted, finding companies that can do that with you, both in terms of the technology, but understanding how to sensorize the equipment in the right places in the right ways, have really big impacts. Finally, I think there's two other points actually. I'm probably taking a long time with this scaling question, but these are the things where are really things that ignite the scale question. Is also understanding the skills. So if you speak to a lot of we'll go into the world of buzzwords for a second at the moment, predictive maintenance, and a lot of the focus of those conversations I hear are around kind of AI skills. Yeah, we need data scientists to do this stuff. I disagree with that, because if the tools are doing the job properly, you don't need to be an AI expert. But what you need is the skills to get the data, so the spectra analysis that you get off, say, predictive maintenance. And how do you interpret that? How do you take that and say, your classical Cat 2, Cat 3 vibration analysts, being able to take that and go, you know what? You've got a flat spot on one of the rolling elements, or you've got an issue with a lubrication regime, or the shaft's gone out of alignment. So it's about the skills, I think, that really make a difference are the people who can interpret the data and put them into meaningful outcomes. And that's actually a rarity. So, the other reason is you don't have people to really use the system to the greatest advantage. And obviously that has a knock-on effect on terms of the ROI question. And if we're all honest as well, the final one is just culture. We have, in the world of maintenance, it has been a world of break fix or planned maintenance. The vast majority of manufacturers are still kind of fundamentally working in that world. And, for some businesses and some sizes and complexity of processes, that actually is okay. But actually, if you want to go predictive maintenance around critical assets within your production facility and across your production facilities, which we obviously talk about scale, then you actually really need to start changing the way of working. Start saying, you know what, we're not going to wait until something breaks. We're going to proactively get in there and deal with it in the best window and the earliest window we have. And that, from a business point of view, improves obviously your availability of assets, has a knock-on effect on OEE and the product you can get out the door. But actually, it has another really important knock-on effect of that change of get people seeing the benefit of getting in earlier. It also has, maintenance teams feel better because actually fewer things break because you're getting ahead of the game, not reacting to the situation. And the stress levels change, and it's a really nice. And I've seen this several times when predictive maintenance works really well. The whole philosophy of the maintenance team changes from the guys that are running around like headless chickens trying to keep things up and running to the teams that are actually keeping and building, improving. And today, it's not stupid, but there is energy costs are going up again. Well-maintained equipment uses less energy. There's a financial benefit in the business. and you're increasing the life of those assets because you're maintaining them well rather than waiting till they break. So your capital costs go down, and actually, for many cases, and this is a real kind of hint in terms of business case, there's a massive impact in sustainability agenda there as well.
Mm. Yeah, and it's interesting you talk about the broader use cases, because I think as a market, it's moved much more beyond, let's look at reducing unplanned downtime, and that used to be the only metric, and maybe it's still a key metric, but even talking to colleagues on this podcast, even things like health and safety, and obviously you can't put a price on that, clearly, but even that's been talked about, with customers as like something actually it can help with that. If you're proactive about fixing things, you can sort of save any sort of risky, repairs that may need to happen.
Well, I mean, operating in a safe operating environment is obviously number one. Quality comes two when compared to safety.
Yeah.
And so we can't argue that, but I think one of the things that predictive maintenance does is it takes the pressure off those moments of failure. When those moments of failure, people are rushing, and often when people are put under pressurized situations, it's unfortunate mistakes get made in those. So it does change that dynamic quite significantly.
No, absolutely, and that makes a lot of sense. Well, I never really thought about it that way. But some of what you were saying before, and I know you apologise for talking a lot, but A, we're on a podcast, and B, the less I talk and the more you talk, I think it's better for everyone. But there was so much in there. I mean, the thing about culture, I want to just start there, because that's something that we often talk about within Siemens as well, as such a key part of scalability. But you also mentioned sort of a technical aspect as well. So I think, Nick, from your point of view, how do you sort of bring those two very opposing sides together? And maybe we could even talk about some of the stakeholders involved, because there's very contrasting stakeholders involved in a predictive maintenance project, and how does that all stay aligned with different priorities? It's a big question, I know. I'd love to.
Yeah, I'm trying to mentally unpack that right now.
We can break it down a bit. We can break it down. Let's
start at the top, shall we? Because it's always easier to start at the top.
Yeah.
I think a lot of executives view predictive maintenance as a cost in the business, rather than an investment and a cost-saving opportunity. So the first thing of cultural change at the top is the ability to effectively connect how predictive maintenance affects their KPIs in their world. And they're different to the maintenance guys. So having that, is kind of linked to the ROI question, but ROI is financially measured. But at the end of the day, is like we talked about safety a minute ago. So can you say to your operations director, you know what, if we do this, it will improve the safety on the shop floor? That's something and a clear why. Again, back to that simple example that illustrates the point rather than the metrics. Those things will stick in their head. And that will start driving that leadership buy-in to do something different. So we talked about the top, and then let's get down to the kind of the boots on the ground and actually the people who do the job, so the maintenance engineers and the technicians. How does that change their world as well? And a part of that is, I've covered some of that already, is about changing their day. Their days doesn't become a constant firefighting. It's about actually getting ahead of the game, keeping things running smoothly, that pressure levels drop. In reality, there's again, PwC report did a report last year, and I'm reading off the screen because quite often I can't memorize all these stats off the top of my head, but about 25% of maintenance teams use data to make decisions.
Wow, yeah.
That's really quite low. Now, that's a reflection on that kind of planned or break fix type approach, wait until something breaks. Maybe the data is that nothing's running. But when you look at those sort of data points, it's that shift from reactive to proactive. And that has a profound effect from a cultural buy-in. But it's not about the technology. It's about how it changes the day for a maintenance engineer. And also, I think I guess part of that is also about the training you give them. I spend a lot of time talking about workforce challenges in manufacturing as well. That's one of my passions, and one of my passions is that I want to see this more from the people, the frontline workers, the operators, and that perspective, as opposed to the management perspective of how skills are needed. But actually, the training you give to maintenance engineers and technicians that are then about how to use the tools helps them to actually understand, okay, I get how that can be used. I don't have to walk around listening around, seeing what's rattling this week versus last week. They know their assets, they know what's going on. But this is like a secret window. You train them into this secret window of, actually, this is how it's performing, this is how it's working. You can't hear this yet, but we're starting to see something change. And those skills are actually adding value to them as an individual as well. Let's be honest. If they can use these tools, they're more valuable in the marketplace. So you're investing in them as well as investing in the technology. And then there's the bum fight, isn't there? Let's be honest. There's always a bum fight with these projects on cultural change between IT, operations, and maintenance. Yeah, there's always, operations won't allow you to get on and try and implement this because they're running 24-hour shifts 7 days a week. Yeah, IT won't go there because they'll go, well, that's not really our project. I want that to be our project. And I want that connected in here, but we've got all these huge barriers of security and technology to overcome. You can't connect that to our network conversation. To the maintenance teams that just want something done to make their world better. So actually getting those people together and say, look, the objective is this is the goal, and we've got to work together rather than our traditional silos which we operate on. It makes a massive difference in terms of driving a success of a project to get these things over the line and start seeing the benefits as well.
And I guess, quite obviously the key is to, it's collaboration with and we know ourselves that collaboration is key to the success of these projects. But how do you sort of foster collaboration between those, the different areas of a business which have completely different focuses, priorities, viewpoints on things? How can you in reality bring people together?
Well, I started off by talking about leadership. The problem is that all organizations have some degree of hierarchy, but ultimately the further up the organization you go, the number of invested players becomes less and less. So actually having some level of alignment at leadership, but buy-in below them, maybe you're a couple of levels down in management, that's normally a really good place to start. So there is a shared goal, a shared outcome that we need to get to as an organization. And if you agree and align on those shared outcomes, then those barriers start diminishing because we're all working towards a common goal. Whereas IT want to just work on security, not introduce new systems into their business, those sort of things. But they also have a responsibility not to be a barrier, but also to enable the organization to operate efficiently as well. So, having those dialogues to say, look, this is the goal, this is the business goal, here's the financial return. We need to work together to make that happen. Or do it in a way that those barriers disappear. I've seen a lot of predictive maintenance solutions now that are not even touching the networks. So you're implementing the sensors. The sensors are connected to gateways. Those gateways are communicating to a SaaS platform. There is security across that chain, but they're not placing a cybersecurity risk into the actual operations of the business. So there are ways of trying to skin this cat, so to speak, that minimizes some of those barriers as well.
I get, in terms of sort of other issues that might cloud, this is more about the market in general, but is there sort of misconceptions about what PDM is? Because I guess even within an organization, there might be different definitions floating around, but we know in the market, there's some products that say they're predictive predictive maintenance when they're not, or they do AI when they don't. And I guess this adds to this internal confusion as well. I'm going to guess.
Well, I mean, you work for an organisation called Siemens, and they have a PDM solution and a PDM solution. One being product data management and one being predictive maintenance. So the world of acronyms is a nightmare. I spend a lot of time decoding buzzwords to what do they really mean, and acronyms to what do they really mean. And one of my favourite right now, by the way, is agentic AI. Everybody's still, that sounds cool. What does that mean? So I think the problem is there are absolute themes and topics in the industry that get a lot of press and noise. So AI, you mentioned it, yeah, is absolutely one. You can't go 2 days without a new report on the way that AI is going to revolutionize industry and everything else around the world, including my coffee machine in my kitchen. The reality is that very few solutions are really truly AI centric. One of the key things I think is about data. First of all, in the world of predictive maintenance, you kind of need to predict when something's going to fail. Now, that requires knowing failure modes, probabilities of failure modes. It requires understanding the condition of the asset of where you are in that curve. And it requires having the right data in the right context to apply that. And we have to start with that data quality. Are you measuring the right things at the right points and gaining that right data to make that analysis to predict something? Incorrect threshold settings on sensors, so your vibration, your RMS levels, whatever, those things will have a profound effect on garbage in, garbage out. You get, and that actually is a killer, by the way. You do that wrong, people's confidence level in the solutions you deploy kind of evaporate because it's just a world of noise you're dealing with. It doesn't help the daily situation. So bringing that data into something that it becomes meaningful, setting thresholds, for example, that are really showing the asset you're looking at and the operation it's performing, and is that really starting to go into a warning alert or a warning status? Those things is where a lot of predictive maintenance is today. There are a few solutions out there that are now going into the prediction of that, but I think there's a risk here. I think, well, actually, let me put this in a different way, in a more positive way, I guess, is the prediction. I think stage one is predicting what that failure mode is. So is it, as I mentioned at the beginning, a misalignment of a shaft? Is it a mechanical failure somewhere? Is it, you got a problem with the bearing, in a raceway issues or something else like that? Using the data, and there are quite, simple, logical kind of fault connections where you've got multiple failure states or multiple alert states, would help you understand and predict what that failure mode is. Then the next piece where it gets cleverer, and again, this is where it gets harder because you get a lot more false positives here. And what I mean by false positive is something isn't going to fail, but you're getting told it is going to fail. And that's about training and time. So the next stage is about when. So you know it's going to fail, why it's going to fail. The next question is, when is it going to fail? And that's a lot harder because that not only does you have to take the failure mode, you need to understand where it is in that process of failure, and you need to predict events. Well, look, we're here, but it's got weeks left of runtime, and that's hugely contingent on what are you going to produce in the next week. Are you going to run it 50% of the time? Are you going to run it 100% of the time? So that kind of window, and actually, if we're honest, well, that's all that's trying to do is understand how long you can run it before it fails. So we're almost back into that break fix reactive world there. So to me, all that cool stuff that we talk about, it will get better over time, and I'm absolutely confident that this is the direction. But where we are right now, there is more false positives and marketing, if I'm honest, marketing noise in this space than actually the practical application. And I think things like understanding the failure mode and relying on the skills, the knowledge, and the intelligence of the maintenance teams that live and breathe those assets on a day-to-day basis is a massive step forward. Because if you can predict the failure mode, the people you have in your business will probably know, okay, it's that machine and that's been running like this. I reckon we've probably got another week. Let's order that spare part in now because I know the supplier of that motor will get us a new product, a new motor in the next 3 days or something else like that.
That's interesting. And I guess if we apply this to scaling as well, so in terms of, and we're jumping ahead a little bit, I guess, but in terms of the best practices that drive success, I think we've talked a lot about predictive maintenance, success and cultural factors, technical factors. But if we apply that to scaling, what do organisations need to have in mind when thinking about scaling?
So I think we need to go back to my original point. Understand scaling in 2 dimensions. Dimensions within the plant, so the number of assets you're monitoring versus the number of plants you're monitoring. And there'll be a break-even point on both those axes. And when I see things or predictive maintenance, I use the word pilot, I shouldn't have done so. When I see predictive maintenance projects scale and be successful, is when they kind of start small. It's not, you don't go for day one, we're going to measure everything. It's measuring those 2 or 3 critical things that you've had either a lot of problems with that cause issues or are known as the critical assets. Start with those, demonstrate the benefit, and then still don't have the aspiration to measure everything, but then you can kind of progress on that axis within your plant or moving to either the next line or perhaps the next set of critical assets. And at some point you go, that's good. We're measuring really cheap motors on there that we don't need to do that, or they don't fail. So keep that and scale across that axis. That success story within that plant and in those lines can then go, right, how do we replicate that across other plants and facilities? And part of that is, are the product lines the same? Are the manufacturing processes the same? Are the assets the same? And then you use that and say, well, look, we're all using the same compressor. We all have compressors in the plants. We may use 3 different manufacturers of compressors in the plant. But actually, we can use this technology and deploy these on all these because our technology is focused on deploying on legacy equipment. And then you start getting that scale. And then for the first time, you start getting the overall health and performance of not just your lines, but your plants as well. And then that ball starts. But it all starts with starting small, demonstrating it. And that is both from a financial perspective, but also around that cultural change. Because people don't believe this stuff works. The amount of maintenance technicians and engineers going, yeah, but it doesn't quite work. There's a great example, by the way, where I've got one. I had a company using condition-based monitoring, and it was quite new in its implementation. And there was an air knife, so it's basically a big fan. And the vibration of the spectra coming off there was indicating a bearing failure. And actually what it was is it was actually caused by dirt on the blades, creating an imbalance. But the spectra actually gave exactly the same replication. Now that was really important learning. So important learning in twofold. One is everything you see on a screen doesn't necessarily equal the real world in the production environment. But it actually was a great opportunity to connect the skepticism of the maintenance teams and the reality on the ground with the data, and then say, well, look, even if it wasn't the bearing, it was imbalance, you went and cleaned it. Because that imbalance over time would create a secondary issue. So actually, everybody started going, oh, yeah, okay. So maybe it told me the wrong thing, but it told me something was out of kilter, irrespective. And that helped me. And you go, no, they could probably go down the line, they'll hear something as well. Maybe they hear something and they go back and then look at the predictive maintenance system and actually saying, well, look, okay, it is trending. It hasn't hit the alert yet, but it is trending upwards. Okay, so it's gradual correlations of those, and the only way you can do that is to start small and get some really good proof points. And I use this phrase a lot: Yodas. So we all love Star Wars. I mean, behind me you've got Muppets. So one day I will get a Yoda behind me. But what I mean by Yodas, and this is another thing about scaling and success, is obviously you see a lot of very important people walking around in suits at times talking about the huge benefits you get from this, but they don't really change people's opinions. Yoda is the wise engineer that's been around your business for many years, that everybody actually all the engineers go to and listen, because when Yoda says something's wrong, everybody goes, yes, it is something wrong. Everybody listens to them, their experience, their knowledge, their wise position. And if you can identify the Yodas in your operations that says, you know what, predictive maintenance is the future, and this is why I believe it's the way to work forward, actually you get a lot of momentum because you get support behind your Yoda. The challenge is Yodas are difficult to convince. So you've got to be spot on what you need to do. But actually, if you get your Yodas on side, then that whole scaling journey and bringing the rest of the organization comes on. And the other interesting thing is, whilst the engineers listen to Yoda, Yoda often carries a lot of respect back up into the High Jedi Council, or let's call it the management team in your operations. So that has a two-pronged approach of actually getting people buying upwards and engagement and alignment downwards as well.
And you're right. And I'm sorry, I was just thinking through that as well. So you say, like, horizontally and vertically as well is equally important, you're saying?
Yeah, absolutely. Because if you don't, you can have all the managers saying this is the perfect solution, but if nobody uses it, it never returns its value. So you kind of got to get the people who do the day job on board. And as I've said, one of the most successful things I've done in my career is generally identify quite quickly who are the Yodas to get them on board. And actually, they're great to challenge you. They're great to challenge you and say, is this the right thing? Is there a different way of doing it? And it really helps your own perspective in driving these projects forward as well.
Yeah, and within Siemens as well. So with our deployment of predictive maintenance, we have a similar, what we call PDM champions. So as we talk about a champion, someone who's going to really drive the project, be the point of contact, be the link between us as a vendor and them, and working very closely with them. And they're usually the big driver of using the platform, of getting buy-in, and for the scale aspect as well. Yeah, so we see that as a very important role.
You say champion, I say Yoda.
Exactly, but it's just great. We're talking about the very similar things as well. And I guess in terms of, I see we're rapidly running out of time, so I wanted to talk about the sort of the business case angle as well. So hopefully seen success, maybe started on a line, and like I say, starting small, going bigger and bigger and bigger, but as you get sort of bigger deployments, or maybe even not, but how do you sort of approach sort of the return on investment and building a business case between the different stages of scaling, let's say? So I'm sure it changes as you go.
So a point I've raised, but I'll keep going back to it because I think it's so important. Financial business cases and spreadsheets are all well and good, but real world examples of where things fail, have caused problems, and generally give everybody a real pain. Yeah, it's a real pain, something they've experienced themselves, not just in the KPIs they're measured with, but all the problems they've had to deal with as a consequence of it. And that's really good for leaderships, by the way. That's the starting point for me in a business case. You can build the spreadsheets up, and the amount of business cases I've written over the years I've been working. But actually, I always see there's the real world examples, those stories everybody relates to, so it brings the financial case to life. Think about the secondary but also tangible benefits as well. So unplanned downtime, you mentioned that's the traditional case, but actually with predictive maintenance, maintenance costs go down, about 20 to 25%. Asset life can be extended by about 20%. And that's some data out of the US, actually. The Department of Energy a couple of years ago had that. So, you're now touching on not just the downtime question, but the kind of cause and effect and the opportunities that you have that are quite tangible to measure because you're not replacing equipment so regularly. And that has a direct cost on the bottom line of companies. And then the final area, I think, and it depends how far you go, but sustainability. It uses well-maintained equipment, is well known. It uses less energy. Can you have a well-maintained versus is traditionally maintained machines? Do energy monitoring it, see the difference of it. That's hard money, coming out of the business. And the ESG targets you have. A great example, SKF on their bearings, a remanufactured bearing, I think it uses 90% less energy and has 80% of the carbon footprint of a new bearing. So, running things to failure basically means you've got the scrap of that equipment. You can then you don't run it to failure. You take it out early, you maintain it. You're actually having a significant downstream impact in terms of sustainability. That one's a little bit more kind of, I'd say, on the edge, but it is real. It is real in terms of a business case. So make it, I can use the word real again, but make it real with real success stories and examples of where people have seen the pain and how you avoid the pain they've had. Link it to direct real cost savings and not just about unplanned downtime. And then look at the other things it has, like the sustainability angle as well.
Yeah, and it's interesting. It does link back to what we talked about, that when you're looking at building a business case, it's not just about, it's looking, of course, it's looking for the problems you'll try and solve and maybe the critical assets you need to manage. But it's also thinking beyond maybe just sort of unplanned downtime and the vast potential of what predictive maintenance can solve. I think it's really the key. And look at other use cases, let's say.
Yeah, I'm sure the finance director will get really excited because you can actually keep the machine running 2 years longer because of this, rather than replace it, and not having to take the capital investment they need. So I think there are some really strong lines there that could be actually pursued. And it's very, very dependent on the situation of the company and where that company is, where it is financially and what their priorities are. And, I think that, I didn't actually mention that, but understanding those things before you write your business case are going to be also really critical. Look at your goals, your business goals of the next 3 to 5 years. Also tie it into those, and without doing this, how much harder it is to achieve those goals.
Exactly, 100%. And so just to finish, we like to do this on the podcast. It's just, if we're going to sort of finish here, lots of great tips and information and a lot to take in. But if Nick, just to sort of summarize, maybe 3 key things for companies or organizations to think about if they want to get started with predictive maintenance and want to scale and build that business case to scale, what should they be thinking about first of all?
So I think the 3 things, the 3 takeaways would be clear and make it real on why you need to do it. It's not about the technology. It's about the why for your business. So that'd be number 1. That business case is probably more richer when you think about it as a why rather than the financial return. The second one will be start small, really prove it. You don't have to measure everything. Measure those critical assets, show the real impact, and then have a plan on how to scale it across your assets or across similar assets in multiple plants. And then the final thing is people and culture, yeah? This, again, it's technology, but you have to show how people's lives get better on a day-to-day basis. So you could have the most successful technical deployment of PDM in the world, predictive maintenance in the world. If nobody uses it, it delivers 0 value. Just show how it makes people's lives better, improves their job. And that is to me, those 3 things really make a recipe for success. I guess maybe the 3.5 I could do is find the right partner that fits with your organization as well. But that's a 3.5. I'll just throw that in the end. Yeah.
And exactly. It's finding a partner or a vendor that, that works with you as well. I'm talking from a Siemens context, but we're certainly it's not about here's the technology, off you go. It's very much working together to work with you to deliver success, because obviously it benefits everyone for that to happen. So that's the key. You want a vendor who's really working with you and not just supplying you software, as an example.
It's having shared goals. And the shared goal isn't a successful technical deployment. A shared goal is actually improving the uptime, the availability, the safety of your equipment, and actually making the maintenance engineers and technicians' jobs better on a day-to-day basis.
Absolutely. So really great takeaways there as well, and a lot for, I guess, people to think about. But if they wanted to continue the conversation with you, Nick, where's the sort of best place for people to find out about you or keep up to date with what you're doing?
Great question. I hadn't actually thought of an answer to that, but funny enough, I do have a website. So number one, if you want to see what we do, if you go to Nick Leeder, that's with 2 E's, so NickLeeder.com, you'll see what we do there and some good examples of the different steps and how we take manufacturing businesses through that transformational journey. Another one would be to go find Nick Leeder and Co. on LinkedIn. We have a weekly Beyond the Buzzwords newsletter where I talked about it at the beginning. Right now we're talking about the manufacturing mousetrap. The next pieces, next one's going to be around the 7 deadly sins of digital transformation in manufacturing. So there's some great little kind of insights and ideas that you can take away and think about in terms of your own organization.
Fantastic. So what we'll do to make it a bit easier for everyone as well, we'll just link to those to those places in the sort of description as well, so you can access those quite easily. But no, thank you, Nick, for your time today. Really interesting to get, and again, say this a lot, like getting an external perspective as well and bringing that voice to the podcast. So I really appreciate your time, sort of sharing your sort of knowledge and expertise on this topic. And I'd like to say that we'd hope you're back on soon, because I'd love to sort of continue the conversation in other areas as well. But hopefully we haven't scared you off.
No, not at all. Thank you so much.
Thank you, everyone. And thank you, everyone out there, for listening to the podcast. And we'll see you on the next episode.
Please like and subscribe on all major podcast channels, and find out more about Senseye Predictive Maintenance at Siemens.com.